We're looking at proportional reasoning, and the method we're going to use to solve this question is algebraic reasoning. The overall expectation is to solve problems involving proportional reasoning, and specific expectation is solve for unknown value in a proportion using a variety of methods, and we're going to use algebraic reasoning. So here's our inquiry type question. We'll read through it once, and then we'll highlight what's important the second time through. The D'Souza family is going on a trip to Prince Edward Island and back. It is a 1,600 kilometer trip from home to PEI. Determine the total cost of the gas for the D'Souza family's trip to PEI and back if the cost of gas is 128 centimeters per liter and the car uses 9.8 liters per 100 kilometer. Okay, there's a lot of info in there. First things first is that the family is going there to PEI and back. It's a two-way trip. And this 1,600 kilometers from home to PEI is only one way. So we're already going to have to do a calculation with that. Second important stuff, and it's kind of like a part two, I'm going to highlight this in green, is the cost of gas. Okay, the cost of gas is 128 cents per liter. I'm going to highlight this part in yellow again, and the car uses 9.8 liters per 100 kilometers. And that's going to pertain kind of to our part one of the question here, and our green will kind of be our part two. So let's quickly do a quick diagram of what this trip probably looks like. The D'Souza family is traveling from home, and they're driving all the way out to Prince Edward Island, and the trip takes 1,600 kilometers one way, and then they're coming back because they want to go home also. So it's another 1,600 the other way. So in total, the family's traveling, if you add these two together, 3,200 kilometers. So that's going to be important for what we're doing. Now, we have two variables. We have our kilometers and the liters the car uses. Let's set those up, our kilometers. We know that the family travels a total of 3,200 kilometers. The amount of liters they use at that point is unknown. We don't know what it is. But we do know from what they've told us in the question, for every 100 kilometers we use, the car uses 9.8 liters of gas, which is good. That will help us on our way. Just as a side note, if we were to drive no kilometers, how many liters would we use? Probably none, which means this is a directly proportional relationship. If we were to draw a graph, a line, this would go directly through the origin, which means we're going to use this type of equation, y is equal to m times x. So, with that being said, we need to figure out what our x and our y variables are going to be, and then what our m variable is going to be. So, our kilometers is our independent, right? Depending on how far we drive, it tells us how many liters we use. So this is our independent, and our independent variable is usually our x value. Okay, there's our x value. And that makes our liters dependent on how far we drive, which means this is our y value. Okay, so with that being said, we'll kind of color code this. Our equation will read y equals m times x. We have to figure out our m. Our x here is kilometers, so we're really looking at liters per kilometer. And that per, that's what this line represents. Per kilometers, it represents 1. So we need to convert this to 1 kilometer. And whatever our liters are at that point, that's what our rate is going to be. Our m is going to be equal to that. So the only part we have information about is this line here, 100 and 9.8. So we're going to convert 100 to the value of 1, which means we'll divide by 100. And we did it to the 100, so we'll also divide the 9.8 by 100. If you use your calculator, you'll find out that if you just move the decimal 2 places over, the value is 0.098. So that's our new rate. So our equation now reads y is equal to 0.098 times x. So this is the equation we're going to use to figure out how many liters the family uses. Now we know the family used 3,200 kilometers. So we're going to plug that in for our x value. Write the rest in black here. Y is equal to 0.098 times that 3,200. So take our calculator out here. It's a more difficult calculation. 0.098 times 3,200 equals 313.6. So 313.6. So y is equal to 313 13.6 liters. So that's the total amount of liters the family uses on this trip. But they're not asking us for liters. They're asking us what the cost is. And this is actually the rate to our cost. So we have to build two new variables. Think of this as a whole other type of question. Our two new variables are the family's cost, which we'll do in green, and how many liters they use. Now this time, our liters is our independent. That's going to be our x value. And their cost is going to be our dependent. This will be our y value. Same type of relationship. It's a y equals m times x. Okay. And we said x will be our liters. And we know how many liters from above. It's 313.6 liters. And our cost is going to be our y value. This is our unknown. Our rate, m, they actually tell us in the question. The question says it uses 128 cents per liter. That's great. So for every 1 liter we use, the cost is 128 cents. And I'm going to convert that to dollars by putting a decimal here. It's $1.28. Okay? So now, that's going to be our rate. Remember, whatever is equivalent to our 1 here, we'll plug that in for our m. So y equals 1.28 times x. And the amount of liters we use is 313.6. We're going to plug that in for x. Y equals 1.28 times 313.6. Again, we'll use our calculator to solve this. 313.6 times 1.28. And lo and behold, the family spends $401 and around that 41 cents. So $401.41 in total for this family's trip. If you'd like to see other ways to solve this question, you can check out our other playlists on proportional